Hello again. We will now begin part 2 of our conversation on finding the area of a regular polygon. Now in today's lesson, what we're going to do is just use some of the terms that we learned in our previous video, and we're going to find the length of the apothem, and we're going to find the perimeter of each figure. And we'll finish up each one tomorrow. So where this one says find the area, it says what is the area you're covering. We're not actually going to find the area in today's video. We're going to find the length of the apothem and the perimeter. So here we go. You are decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides and a radius of about 19.6 inches. We're going to find the apothem and the perimeter. So I'm going to make a note over here. We are finding apothem and we are finding perimeter. Okay, so the perimeter here will be probably the easier part. Each side is 15 inches. It's an octagon, so there's 8 sides. 15 times 8 will be the perimeter. So we've got 15 times 8, 120. So the perimeter is 120 inches. I'll put an underline in that. That's going to be an important piece of information later on. Next is find the apothem. So I'll draw in an apothem here. An apothem goes from the center to a side, and it's perpendicular to that side. Now if I make a right triangle here, I have a side length right here of half of a full side length. So this right here is 7.5 inches. Now in this case, I can use the Pythagorean Theorem to find this length right here. I'll put an A here, that's the apothem. So I've got A squared plus 7.5 squared equals the hypotenuse of this triangle, 19.6 squared. So we'll do minus 7.5 squared on both sides. So A squared equals 19.6 squared minus 7.5 squared is 327.91. And then we will take the square root of both sides. So square root of that previous answer is 18.1. So the apothem is 18.1 inches. And I'll underline that. That will also be some important information. Now for today, that's all we're going to do. Apothem and perimeter. So we'll come down here to our next one. A regular nonagon, so that is a 9-sided polygon, is inscribed in a circle with a radius of 4 units. Find the perimeter and area, but that's not really what we're going to do. We're going to find the perimeter, and we're going to find the apothem today. And we'll deal with area later. Okay, so the perimeter, well, we need a side length in order to do that. We don't have that side length. We don't have an apothem, so here's what we're going to do. We're going to find this angle measure right here. It is a half of a central angle. Okay, so we'll start by finding the measure of a central angle. So central angle equals, to find the measure of that central angle, then angle KLJ, we'll do 360 divided by the number of sides. It's a nonagon, so there are 9 sides, which means there are 9 central angles. So we have 360 divided by 9, and that is 40. Okay, now what's actually really important is this half central angle. And that's 40, the central angle, divided by 2, which is 20 degrees. So right here, I have a 20-degree angle. Okay, now, in order to find the perimeter, I need this length right here. So I'll call this X. So it's the length of segment KM. To find that length, I'm going to use SOHCAHTOA. So I'll write the word right here, SOHCAHTOA. Toa. Now, x is across from that 20, so that is the opposite leg. 4 is the hypotenuse. Opposite leg and hypotenuse, that's right here. Opposite and hypotenuse, which means we are going to use sine. So we have sine of 20 degrees is to 1, as the opposite x is to the hypotenuse 4. So let's cross multiply since we have a number on bottom here. So we have 1x equals 4 times sine of a 20 degree angle. So we have 4 sine 20, and that is 1.368. And I'm going to keep all three of those decimals, 1.368. Now that is this right here. It is not a full side length. It is just half of a side length of this nonagon. So if I want a whole side length, I have to multiply that number by 2, and that's 2.736. Okay, now if I want to turn that into the perimeter, I can multiply that by the number of sides. There are 9 sides. And I get 24.625. So the perimeter is 24.625 units. And I'll underline that. That will be important information when it comes time to find the area. Okay, now what I don't have yet is the apothem. So to find the apothem, I'll look for this right here. I'll call it A for apothem. So I've got a 20 degree angle here. I've got an adjacent leg and a hypotenuse. This time I'm going to use cosine. So we have cosine 20 degrees is to 1, as the adjacent leg is to the hypotenuse. So we'll cross multiply, and we have A times 1 equals 4 times cosine 20 degrees. So 4 cosine 20 is 3.759. And that is the apothem, 3.759 units, and I will underline that. And for now, we'll leave that right where it is, and in our next lesson, we'll come back and use the information to find the area. We'll continue down here to these last 3 problems where it says find the perimeter and area, but that's not what we're going to do right now. We're going to find the perimeter and the apothem. So for each one, perimeter and apothem. Okay, so for our first problem here, I can find this right here by using Pythagorean Theorem. A squared plus b squared equals c squared. So I've got 6.5 squared plus b squared equals 8 squared. So we'll subtract 6.5 squared from both sides. And we've got b squared is 21.75. And then the square root of that answer is 4.664. So this right here is 4.664. Now, if I take that number and multiply it by 2, that gives me a side length of 9.327. Okay, so that's one side length of this pentagon. There are 5 sides, so times 5 gives me the perimeter, 46.637 units. There's the perimeter. Now the apothem is actually given. It's 6.5, so there's no work to do for the apothem. So that's as far as we go with that for now. Okay, now this next one, I'm going to put in a center, and I'll draw in a half of a central angle, using a radius and an apothem. Now this right here is half of a side length, so it's half of 7, so it's 3.5. I really could use this angle measure. So I'll do 360 divided by the number of sides. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. 360 divided by 10. That's 36 degrees. That's a central angle. But what I have here is a half central angle. So 36 divided by 2, and that is 18 degrees. So I have an 18 degree half central angle. Okay, now I'll use sine, cosine, and tangent to find the apothem. Okay, so what I have here is the opposite leg and the adjacent leg. No hypotenuse. Opposite and adjacent, that's tangent. So tangent, 18 degrees, is to 1, as the opposite, 3.5, is to the adjacent A. Now here's a case where I've got a variable in the denominator, so let's switch these and divide. So I have A over 1, or just A, equals 3.5 over tangent 18 degrees. Okay, so 3.5 divided by tangent 18 is 10.772. Okay, so the apothem is 10.772 units. The perimeter, each side is 7. There are 10 sides. 7 times 10 is 70 units. That is the perimeter. And our last one here has an apothem given. It is 5. Okay, so I will make a half central angle here and find this angle, this half central angle. So I've got 360 divided by 3 because it's a triangle. So a central angle is 120 degrees. So I'll do 120 divided by 2 to get a half central angle, and that is 60 degrees. Now this one I'm going to find an exact measure for this side right here using a 30, 60, 90 triangle. So on a 30, 60, 90, and I'll call this right here X. The shortest side is to 1, as the hypotenuse is to 2, and the remaining side is to the square root of 3. So I have X is to the square root of 3, as 5 is to 1. Okay, so that means that X equals 5 times the square root of 3. Okay, so this half side right here is 5 root 3, which means this entire side is 2 times that, or 10 times the square root of 3. So the perimeter, there are 3 sides, and each side is 10 times the square root of 3, so the perimeter is 30 times the square root of 3 units. And the apothem is 5 units.